All right, so to review, again, Chapter 1, you guys have done sections 1.1 A and B, 1.2 A and B, 1.4 and 1.5. That is 4 total sections. They're going to test you on 4 different sections, okay? We're going to try to cover everything we can based on those 4 sections. So first question says, which set of data probably has points closest to the mean? So I put 4 different sets. And I put that the standard deviation for set number 1 is 2.7. The standard deviation for set number 2 is 4.8. Standard deviation for set 3 is 3.6. And the standard deviation for set 4 is 1.5. Now, I did mention this to you guys when I was teaching this. Anybody know what the answer would be? Which set has the points closest to the mean? It's based on standard deviation, obviously, right? If you had to guess, which one do you think would be the one that has the points closest to the mean or closest together? Anybody have a guess? Right? Which one? 1 or 3? I'm going to say that it's not 1 or 3.
2.
It's not 2, so we only have 4, right? It's 4, yeah. Why? Amaro, you were holding up 4. Why? It's the smallest number. Okay, when the standard deviate, think about the name, guys, to deviate, standard deviation. If the number is bigger, that means it's deviating by more. And you don't want deviation. You want it to be as close as possible. So right here, we're going to say set 4 has the smallest standard deviation, so points are closer together. Now, you're not going to have to do this on your test, okay? Because these are the questions that are going to be multiple choice, but I'm just giving you the reason, okay? I'm writing down the reason for you so it makes sense. I don't just want to put set 4 and you're going to study and be like, okay, 1.5, but why? Okay? So set 4 has the smallest standard deviation, so the points are going to be closer together. Now let me draw you a picture really quick here. It's going to be a normal distribution curve, okay? So I'm going to draw a normal distribution curve. Then I'm going to label some stuff. All right, now, I don't like the way they did it on the test, but this is the way it's going to look. Remember the X with the bar means mean, okay? So you might want to write that on your notes. This means mean, okay? So please make sure you write that down on that 3x5 card, or else you're going to look at this and say, what the heck is X bar, right? So that's mean. This is mean plus SD. Mean plus twice SD, mean plus 3 times SD, mean minus SD, mean minus twice SD, and mean minus 3 times SD. And then I'm going to do this. I'm just going to color this in. Here's the question. What percent of the data is shaded? Remember, this is a normal distribution curve. Go ahead. Yes. This is a normal distribution curve. Okay? So remember I told you it'd be to your benefit that you write all your percentages down, right? For this stuff. So let me go ahead and do that for us here. So 34, 13.5, 13.5, 2 and 2, and 0.5, and 0.5. This is a super easy question, but if you don't know those percentages, you're out of luck. Okay? So when they say what percent of the data is included in the shaded region, all you have to do is say, okay, 13.5, 2.0, 0.5, and I'm going to add it all together. So that's a 0, that's a 6, and a 1. So my answer is 16%. That is not a hard problem. This is a really easy problem. But the problem with it is if you don't know those numbers that I put in there in green, because it's not going to be in the test, okay? They're going to show you a picture. They're going to shade something in. You have to make sure you know the percentages. You can memorize them if you want to. But if I were you, maybe just write them on a list. Like, okay, the standard deviations go 0.5 to 13.5, 34, 34, 13.5, right, to and 0.5. Like, at least write that down for yourself so that if they shade something, you just got to add the numbers. Okay? So notice, first two questions, they're relatively simple if you know what you're looking for, right? The standard deviation being small, that means the points are close. If they were to ask you which points are furthest apart, well, then you'd say set number 2, because that's the biggest standard deviation, right? And for this one, they're just going to color something in and say, hey, can you tell me what the percentage is? All right? So are we okay so far for those two? Any questions on that? All right, so let's look at question number 3. So question 3 is going to give us 4 data sets. So I'm going to I'm writing these out kind of like the way the test is going to be formatted for you guys. That way you can kind of be used to it. So set 1, set 2, set 3, and set 4. Here we go. I'll put 10, 15, 27, 48. We'll do 10, 15, 27, 35. 10, 15, 27, 100. And 10, 15, 27, 42. So I'm going to give you 4 data sets. Okay, so there they are. And here's the question. Which set has the largest standard deviation? Again, this is a really easy question if you know what you're looking for, right? Anybody have an idea? 3. Why 3?
27 to 100 is a lot.
Yeah, notice how the first 3 numbers in all the sets are the same, right? But then one of them goes 27 to 48, the other one 27 to 35, 27 to 100, and 27 to 42. Well, that 27 to 100, if standard deviation is all about how close the points stick together, set number 3 is pretty far apart, right? The range for that one is huge. So we're going to say set 3, right? And if you want to put, you could just say because from 27, it jumps to 100. You don't have to put this on the test, okay? You guys are just doing multiple choice for these types of questions. But I'm just giving you a reason so that when you study it, you're like, oh, that's why. Okay, do notice that all the sets have the same first 3 numbers. The last number is different, okay? And only one of them is a huge, okay? So, all right, no big deal. So moving on, what if we give you a problem like this? Find the mean of the following. Okay, so you guys should be able to find a mean for something. So if you want to find the mean, we're supposed to get all those numbers, put them in order, which I already did just for the sake of us not having to worry about that. Right, so we're going to want to get all those numbers, add them up, and divide by the number of numbers, which is 5. There's 5 different numbers. So let's see, I have 2 plus 4, that's 6, 6 plus 7 is 13, 13 plus 10 is 23, and 23 plus 11 would be 44. Wait, did I do that right? Did I jump over? That's 6 and 7 is 13, that's 23, this will be 34 over 5. Okay, so they may have you do an approximation of the mean or something like that. You can use calculators. Since I don't have one, I'm just going to kind of do it by hand. So 34 divided by 5, that's going to be 6. So that's 30 with the 4. So that's going to be approximately, actually not approximately, it's going to be 6.8. That's what it's going to be. 6 4/5 or 6.8. All right, so there's my answer for the mean. If I asked you for the median, okay, what is the median? 7, right? That's the number in the middle. Okay, so if I say what's the median, you're just going to put 7. If I ask you for the mode, which number comes out more often than once? None of them. So what is the mode? Just write none. All right. So here's one that's kind of tough. Because it's a lot of words, but if you know what you're doing, again, it's not going to be terrible, but it is a lot of words. So let me give you this situation here. So we're going to start number 5. Now it is a bit wordy. Okay, now this is a normal distribution problem. They will tell you it's normal distribution. Okay, so it says, what is the range that is within, within 95% of the mean for an average salary of $6,000 with a standard deviation of $2,000. Now, in order to do this, you guys are going to have to be able to draw this out, okay? Like I told you guys, this is a normal distribution problem, okay? This is a normal distribution problem. So, what I'm going to do is I'm going to draw a normal distribution curve. Okay, so it's going to look something like this. I'm going to put my numbers towards the bottom, okay? Just a little easier to draw them out that way. So they said my average was 6,000. That's my mean, 6,000. And then if you guys remember, you just keep adding and subtracting your standard deviation. So the next one will be 6,000 plus 2,000, that's 8,000. The next line will be 10,000. The next line will be 12,000. Remember, you go 3 deviations to the right, 3 to the left. So let's see. To the left will be 4,000. And then 2,000. And then 0. Now, what shaded region represents 95%? Well, I know I'm going to have this for sure, because this right here is 68% of the data. Okay? 95% is when you add the other standard deviation right here. Because if you guys remember, the way I know this is 95% is because remember, this over here is 0.5 and 2%. So that means this is 2% and 0.5%. Okay? So altogether, this is 2.5 and this is 2.5. So that means that's 5 on the edges. So that means the rest on the inside has to be 95%. Okay? So all of this right here from here to here must be 95% of the data. Because on the edges is 2.5 and 2.5. That's 5% total. So everything else must make up 95. So they're saying, what's the range? Well, you're going to say $2,000 to $10,000. That's my range. Any questions on that one? I mean, they give you all the information you need. They say, look, the mean is 6,000. The standard deviation is 2, so you can put all the numbers where you need to. And they say, what's within 95%? Well, as long as you know that 95% is basically everything except for the last two little pieces on the left and right side. That's 95%. Then I colored it in and I said, well, that's from 2 to 10. Right? So there you go. I'm not having to do much calculations in these problems. The mean one I did a little bit, but it's a lot of it is just concept. Do you understand what you've learned? Like, do you get what it is that they're talking about? Because if you do, the question's easy. If you don't, there's not much you can do. You can't like, well, let me add these numbers, and I'll get my answer. Like, no, there's not a lot of that on the multiple choice. They want to make sure you understand what's going on. But there will be a question similar to that. Let me give you one that has a table. So question number 6. Okay. So for question number 6, it says, so if a ball needs to be hit 200 feet, which batter is a more reliable choice? So batter A or batter B. And right now I'll give you the information. The average distance for batter A is 200 feet with a standard deviation of 15 feet. For batter B, the average distance is also 200 feet with a standard deviation of 11 feet. Again, there is zero calculation that you guys have to do this problem. Okay, so you need to hit a ball. Let's say you're trying to play a game where if whoever gets it closest will win, right? And then you're trying to win a prize, and they're like, hey, choose a batter, either A or B, and you want to try to hit it closest to 200 feet. Which batter would you pick, batter A or batter B? Batter B. Why? Yeah, the standard deviation is smaller, which means that most likely if he misses, he might go to 211 feet, or maybe he might go to 189 feet, but the other guy might end up at 215 or 185. Now, it doesn't mean for sure batter B is going to get closer, but if you're going to bet money, then you want to choose the one that has the smaller range, right? So smaller deviation is going to be batter B. So this is going to be our answer right there, batter B. Actually, let me write it out. That way I don't mess with the original problem. Okay, smaller deviation. I'm going to put that in the box here. Smaller SD. All right, now we did do box and whiskers plots, so there will be some of those. Okay, so let me draw one for you guys here. It's gonna look a little different than what we're used to, but it's okay. Same idea. Don't worry about the size that you're drawing it. Just make sure you label it the right numbers that I'm doing. Okay? So I'm just going to kind of do this really quick. I'm just kind of pointing at the numbers. That way we know, like, okay, what exactly are these numbers that he's trying to make us do. So, let's see, here, there. There's one here. I'll put one there. So I'm going to do 68, 69, 70, 71, 72, 73, 74, 75. Okay? So this is going to be our number line. I know it's not uniform. I apologize for that, but I'm just trying to make it as easy as possible because on the test it's going to be like this. It's going to be pretty easy. It's not going to try to hide it. Okay, they're not trying to be tricky with the way they label stuff. So they're going to ask you this. What is the second quartile? I'm going to ask a couple of questions, okay? Because they're going to have multiple questions on box and whiskers, all right? But they'll just ask you one at a time. But I'm going to try to ask you a couple so we can kill like 2 or 3 birds with one stone. So what is the second quartile? What is the interquartile range? And we'll say, what is the lower quartile? Let me pick this up a little bit for you. So 3 different questions. On your test, there will be 3 different problems that ask you these questions. And there might be different graphs as well. But I mean, we can take care of all 3 questions with one graph. So what's another name for the second quartile? Anybody remember? The mean. Or sorry, not the mean. The median. I'm thinking the wrong thing here. The median. So what is the median according to this? 71, right? It's always the dot in the middle. Okay? Now the interquartile range is the difference from the, if you want to call it first to third quartile or lower to upper. So my lower quartile is what? 70. I'm going to put that answer right now on the very bottom. Lower quartile 70. What's my upper quartile? 73. So 73 minus 70 is 3. So those are my answers to this problem. Okay? Again, not difficult. I really don't think, I mean, we've done 7 problems, but we've asked multiple questions. So we're close to like about 10 different practice problems so far. But we really haven't had to do much mathematics to calculate stuff, but you do have to know concept. Okay, what am I looking at? What are they asking? Okay, so it is an easy test that we looked over it this Monday, and we're like, wow, this quizzes test is pretty simple if they know what they're doing, right? If you understand the concept, you're gonna have no problem getting an A on this thing. All right, but if you don't understand, it might be a little tough. So that's why they want us to go over it with you guys, just to make sure that you guys remember. All right. This next one, I'm going to make it open-ended instead of making it like multiple choice. You are going to have multiple choice, but I'm going to make it open-ended. What 5 things, they might call them numbers, are needed to make a box and whiskers plot? Now, in the multiple choice test, they are going to tell you like, oh, they're going to give you 4 options that you can pick from. They might say like range, you need min, you need max, etc. So you got to pick the right one. But what are the 5 things you need? I'll kind of show you the picture up here. What are the 5 pieces of information that you need in order to draw one of these things? Someone give me one of them. A median, all right. We got a median. That would be one thing. Somebody else give me another one. So median, I'm going to mark it, okay? There it is, median. The what? You don't need modes. We need which quartile?
1 and 3.
1 and 3. So we can do first quartile. And you said third quartile. All right, let me go back up to the picture. I'll put a little check mark next to those. What else?
Max.
The max, and what else? And the min. Now, maximum, minimum. Okay, now remember guys, the median, they may call it the second quartile. The first quartile, they may call it the lower quartile. Okay, third quartile, they might call it the upper quartile. So I'm gonna list that right here. I'll put it right here, second Q. This might be the lower Q, and this might be the upper Q. All right, I don't know how they're gonna list them because I forgot. I did see it. I know I saw it, but I forgot what they listed them as. So just make sure you know that those have different names. Again, that's probably something good to write on your 3x5 little cheat sheet. Okay, let me see if there's anything else. Yeah. All right, one more here. Just out of curiosity, this will kind of help us out here. So we did max and min, so there we go. How much information is held within that range right there? 25. What about like this big one right here? Yeah, 25%. Every single one of these things holds 25%, even if it doesn't look like it, okay? That's why they're called quartiles, because they hold a quarter of the information. Okay, that's why they call them quartiles, right? The same like when you go buy a quart of milk. Why is it called a quart? Because it's a quarter of a gallon, right? They just didn't name it a quart. I mean, it's a quarter of a gallon, therefore it's a quart, right? So quartiles mean quarters of information. That's why we have 4 of them, right? We have the lower, right? The second, the third, and the very last one. We don't name it, but that's where your max is. We have 4 parts to it. So, if I were to ask you, maybe I won't even label this as question 9, and then we'll stop from here, okay? But if I were to ask you, how much information is held in here? What would you say? 50%, right? So that would hold 50% of your information. There's going to be a question like that on your quiz or your test where they're going to say, hey, from 70 to 75, how much information is being held? What do you guys think? From 70 to 75, 75%. If they say from 68 to 71, how much information is being held? 50, okay? They're going to ask you something like that. Okay? So we'll stop there. We'll continue tomorrow and see how much more we can get done. But do you guys see what I mean? It's not like the big part of your test, that multiple choice test, it doesn't ask you to do a lot of math, but it does ask you to understand it. Okay? So just go over this tonight if you can, and tomorrow we'll continue.
Okay, yeah, but we should add there.